And basically it goes like this. It says we have two capacitors. One of them is 2 microfarads and the other one's 4 microfarads. We connect them in parallel across a 300 volt source battery. What is the total energy stored in the capacitors? The total energy stored in the capacitors. So we have to use a little bit of knowledge of circuits combined with the knowledge of capacitors to figure that out. So what we have is some kind of source that's 300 volts. You could put a battery symbol there if you want. I'm just going to put 300 volts there. And we have one capacitor. It tells us they're in parallel. So I'm going to put 2 capacitors basically in parallel. This guy is 2 microfarads and this one is 4 microfarads. And the question is, what's the total energy stored in the capacitor? Well, what you need to realize first out of the gate is that whenever you have anything, capacitors or later on we talk about resistors or anything, if they're directly in parallel with this battery, then the voltage across this capacitor is 300 volts and the voltage across this capacitor is also 300 volts because they're directly connected in parallel to that battery. You have to know that. That's really the only trick to solving this problem. So in a capacitor in general is 1/2 CV squared. So see, we would use this form because we know the capacitance and we know the voltage. All right, and since we know the voltage across both, it's going to be 1/2. This guy, capacitance, is 2 times 10 to the negative 6. The voltage across this guy is 300 volts squared. So that's the energy in this guy plus the energy stored in this guy. 1/2, 4 times 10 to the minus 6 times 300 squared. It's also 300 volts because it's connected directly to the battery. That's really the only trick. If you didn't understand circuits at all, you wouldn't know what voltage to put there. You wouldn't be quite sure. So now that we have this, you just literally plug this in your calculator and you'll get 0.09 plus, you put that in your calculator, you'll get 0.18. So when you add them both together, you'll get 0.27 joules. That's how much energy in joules is stored in there. Now there's more than one way to do a problem. If you wanted to do it differently, you could combine these capacitors into an equivalent capacitance, like we learned how to do a couple sections ago. And then you could use that equivalent capacitors, like one big capacitor there, and then do 1/2 CV squared using the equivalent capacitance. But I think you can kind of see you're going to get the same answer because if we add these, because in capacitors in parallel, we just add the values of the capacitance. So we would get 6 microfarads for that new capacitance. So we would have 1/2 times 6 microfarads times 300 squared, and we would get the same thing because we're just breaking it out here, adding it up a little bit separately, but it's really exactly the same thing. So there's more than one way to do a problem, but in this case I chose to add them up individually, mostly so you can see how things are added together and how the circuit's really working.